You're on mute.
Okay. Okay. I'm sorry.
We cannot hear you.
Yeah. Okay. Can you hear us now? Yeah. Can you hear us?
Yeah, we can hear you. Go ahead.
Okay. Okay. Hello. And thanks for everything. My name is Ala Andrade.
My name is Nada Andrade. We're from Jordan.
And it's nice to meet you all.
Okay, thank you so much. Londa will begin, and then we'll have Jacob. If he's not here, we'll have you guys then, okay? Go ahead.
My partner Jacob Shaw will represent the petitioner, the people in this case. Today, the question in front of this court is a very simple one. Is oil a finite resource? I will speak on the first point of error, how oil is created. This is a fundamental aspect of this entire case. We will prove what oil actually is, how it's created, and what is happening in oil markets today. To do so, we pose a question. Why does everyone seem to believe in the Hertz peak oil theory? Why does the public believe in this theory? Within our arguments, I present convincing evidence that peak oil theory is based on false premises, that oil is a finite resource, and I will show how oil is actually created. Sir Fred Hoyle in 1982 commented, the suggestion that petroleum might arise from some transformation of squash fish or biological detritus is surely the slightest notion to have been entertained by a substantial number of people over an extended period of time. Sir Fred Hoyle, FRS 1982. Charlie E. Melton and AAA Gardini in 1983 explained the general concept of petroleum formation by biogenic mechanism has been firmly entrenched for a long period of time, but there has been no accumulation of a convincing experimental evidence in support of this belief. Currently, the publicly held theory is that oil and gas are both driven through the nature and lengthy decomposition of organic detritus. Therefore, people would naturally believe that oil is a finite resource and that we will eventually run out. In this courtroom today, we will show you that oil and gas are continuously formed and replaced from a purely physical and chemical thermodynamic process, continuously regenerates oil from ultra-deep location 19,000 meters deep. The inference here that oil may perhaps not be a finite resource and that there is plenty of it. First, oil and gas origins, biogenic or abiotic. Do oil and gas originate from a biological decomposition or organic material, or do they originate simply through the natural, physical, and chemical thermodynamic process involving just heat and pressure? It is notable that the whole of Hertz peak theory of peak oil rests completely on the assumption that oil is biogenic in origin. Therefore, oil is a finite resource. Simply everyone believes this because everyone believes that this is a proven fact. I have also read the biogenic theory directly contradicts and offends the second law of thermodynamics. Evidence of Western biogenic theory of oil formations. First, in 1757, Russian scientist Milaho Lomonosov put forward a hypothesis and suggested that oil came from detritus. This theory was first introduced by George Agricola in 1557. George based his work on Greek Aristotle's work in 1757, applying a little more observation and limited analytical tools available in his time. Russian scholar Milaho V. Lomonosov is generally considered to have farther the theory of crude oil, after percolating for a great duration of time, might originate from a biological material. The notion that oil is a fossil fuel was first proposed by Russian scholar Milaho Lomonosov in 1757. Lomonosov's rudimentary hypothesis based on a limited base of scientific knowledge that existed at the time, and on his own simple observation was that rock oil originate from tiny bodies of animals buried in sediment, which was under the influence of increased temperature and pressure acting during an unimaginable long period of time transformed into rock oil. 2.5 centuries later, Lomonosov's theory remains as it was in 1757, an unimproved and entirely speculative hypothesis. Returning once again in the Wall Street Journal, we find that although the world has been drilling for oil for generations, little is known about the nature and the resource of the underground activities that led to its creation. In spite of the great amount of scientific research, there remains many unresolved questions regarding its origin. Doesn't that seem a little bit odd what we're talking here? After all, about a resource that by all accounts plays a critical role in a vast area of human endeavors. Accounts petroleum is a raw ingredient of 70,000 manufactured products, including medicine, synthetic fabrics, fertilizer, paints, varnish, acrylics, plastic, and cosmetics. By many accounts, the very survival of the human race is entirely dependent on the ability of petroleum. And yet, we know almost nothing about this most life-sustaining of Earth's resource. And even though, by our surely accounts, well is about to run dry, no one seems to be overly concerned of the understanding of the nature and the origins of the so-called fossil fuels. We are rather content with continuing to embrace the unapproval of the 18th century that is, if subjected to any sort of logical analysis, seems ludicrous. As anyone who stayed awake during high school class knows that oil came from dinosaurs. I remember as a student hearing my teacher go over and over the fact that oil was a fossil fuel and we were running out of it. It seemed a reasonable enough idea at the time from a perspective of a 16-year-old. But as an adult, you really stop to give it some thought. Doesn't that idea seem, what's the word I'm looking for here? Oh yeah, I remember. Preposterous. How does dinosaurs help possibly create the planet's vast oil fields? Did millions or even billions of them die at the very same time at the very same place? Were the dinosaurs in Jonestown a grand scale occurring location all across the planet? And how did they all get buried so quickly? Because if they weren't buried right away, wouldn't they just have decomposed or become consumed by scavengers? And how much oil have you really squeezed up on a barrel of oil? How many barrels of oil have we used so far? If dinosaurs caused the oil field, or more correctly, their dead bodies decaying caused the oil, then shouldn't it be a simple formula to figure out how much dinosaurs it took to make oil? Isn't this science in reverse? If so, if oil were a fossil fuel, could you not figure out one simple fact? Also, wouldn't that make all oil the same age? Wait, if all oil were the same age, that would mean that dinosaurs all die at the same time, correct? Maybe there was some type of catalytic event that caused the sudden extinction of dinosaurs and also buried them, like the impact of an asteroid or a comet. But even so, you wouldn't think that all the dinosaurs would have been huddled together, waiting to become oil fields. And besides, scientists are now backing away of the mass extinction theory. Doesn't this mean that without a mass extinction theory, we would not have oil as a fossil fuel? Does it also mean that since oil we have today in oil fields was all made at one time, that all oil had to come from some sort of sudden extinction? Then if dinosaurs lived for millions of years before, what did their dead bodies produce? Therefore, it would take a pretty big pile of dead dinosaurs to account of estimate of 660 billion barrels of oil in the Middle East. I don't know what the percentage of dinosaur carcass a barrel oil conversation rate is, but it does seem like it would take a lot of dinosaurs. Even if we generally allowed that a single dinosaur could yield 5 barrels of oil. An assumption, but let's play along. More than 130 billion dinosaurs would have been similarly entombed in just one small region of the world. But were there really hundreds and billions of dinosaurs roaming the earth? If so, then one wonders why there's all these talks about overpopulation and scarce resource when we are currently dealing is just a few billions of human population on the same earth. Could the earth have had 130 billion dinosaurs in one place like in the Middle East? Now, you would have to multiply that with the United States, Mexico, Venezuela, Russia, Nigeria, and all the other leading oil-producing areas of the world. Quickly, you will see that we would have had over 1 trillion dinosaurs on the earth, all dying at one time. We have found some fossil fuels, but have we found them in that type of scale? The answer was resounding no. And why the Middle East? Was that some region? Was that some kind of region, kind of mecca for the dinosaurs? Was it its climate or the lack of water or vegetation that drew them there? Maybe it was like a great valley in the Land Before Time movies. Or maybe the dinosaurs had to cross the Middle East to get to the Great Valley, but they've never made it because they just budged down into the desert and until they became cans of 10W motor oil. Another version of the fossil fuel theory story holds that microscopic animal carcass and other biological matter gathered on the world's seafloor with organic matter then being covered over with sediment over the course of millions of years. You wouldn't think, however, that biological matters would decompose long before being covered over with sediment. But I guess not, and I guess there was no bottom feeders in those days to clear the ocean floors of organic debris. Fair enough, but I still don't understand how these massive piles of biological detritus would stimulate of 100 of billions of tons of matter could just suddenly appeared so they can just sit there undisturbed for millions of years as they were covered over with sediment. I can understand how biologically detritus would accumulate over time, mixed with sediments, but that wouldn't really create the conditions of a generation of vast reservoirs of crude oil. So I guess I might be missing something here. This theory makes some sense, correct? Have we found that most cases that place has been produced oils in the past, West Texas and the Middle East, for example, we're old seabeds, so maybe the theory is correct. It wasn't the dinosaurs entirely, it was all the plants and animals in the ocean that died. That makes perfect sense until you apply some questions. Did all the plants and animals die in the ocean at once? How can you have oil created from the surface of the earth downward and have oil on the top the same age as the bottom? Simply, you can't. Because according to their own theory, the oil had to be made up all at once. For example, let's look at a cook prepared a large kettle of soup. He puts the kettle of soup, heats the kettle slowly, and then adds different ingredient parts of the soup. As the soup is cooking, he continues to add ingredients. He adds ingredients until the exact same time the soup is served. Would all the ingredients be cooked? Would all the ingredients be done? The answer is, of course, not. No. I realize that this is a soup and it's not oil, but the analogy is very much the same. You must question the fact that biologically speaking, for oil to be biotic, it would have to have a single source or cause, and would have to be cooked from the bottom up, not the top down. This means clearly that oil is a fossil fuel. Fossils have to be found at the base of deposits of oil. That means fossils would have been found at levels deeper than oil is currently being pumped at. Today, Russia has many oil wells that are overly 30,000 feet deep, yet the deepest fossil fuel has been found is 16,000 feet below the surface of the earth. In conclusion, let's compare the two theories of oil and oil was created and see which one makes more sense. In the Lomonosov theory in 1757, you either have trillions of dinosaurs dying at the same time and plants and animals in the ocean dying. After they die, they all decay at the same time and create oil. Cross-apply these factors. First, for oil to be a fossil fuel, we would have to be overpopulated with dinosaurs. Second, they all have to die at the same time. Third, oil on top of the oil field would have to be newer than oil on the bottom of the field. Fourth, fossil fuels would have to be found at the bottom of all areas that have been drilled. The interesting fact is that none of this happened. Bones of dinosaurs have not been found numerous sufficient to justify point 1. No scientific has been shown to cause point 2. The age of oil in the field doesn't differ, and fossils have been found only to 16,000 feet, even though they're producing wells that have been dug as twice as deep. Whereabouts the abiotic petroleum hypothesis first gained significant exposure outside the Soviet Union during the 1977 gasoline crisis, when Cornell astrophysics Thomas Gold published an editorial Wall Street Journal in which he claimed the most deep hydrocarbons are generally abiotically in the mantle and migrate to the crust, where they act as an energy source of microbes producing a deep microbial ecosystem, the deep hot biosphere. That may rival the surface biosphere in mass and volume. The organic remains of microbes in the deep hot biosphere represents the source of biological molecules in petroleum as a biological overprint onto an abiotic organic mixture. The proposal contains that implicit concession that the biological molecules in petroleum cannot be generated by polymerization of methane. Echoing some of the previous arguments of Russian-Ukrainian school, both present several lines of evidence of abiotic petroleum, including, first, the presence of clearly abiotic hydrocarbons and organic molecules in meteorites and other solar system bodies. Second, plausible synthetic pathways of mantle hydrocarbon production. Third, the association of hydrocarbon deposits with helium and other trace gases posthumously of the mantle sources. Fourth, the existence of extensive deep microbial communities that impart an overprint of an biomarker onto the abiotic petroleum. Fifth, the tendency of hydrocarbon reservoirs to occur at many depths in a single locally, implying an underlying deep source. Sixth, the distribution of hydrocarbon deposits related to underlying mantle structures. Seven, the distribution of metals and other trace elements in petroleum, which correlate more strongly with chondrite decomposition that presumes crustal source. And eight, the occurrence of hydrocarbon in non-sedimentary formations such as crystalline rock. Clearly, looking at the both abiotic and biotic theories of the creation of oil, we can see which one is scientific and which one is not based on facts. If there are no further questions, I would retire and allow my partner Jacob Shaw to stand and present the second point of error. We pray you vote for the petitioner. Thank you.
Since Jacob's not here, ask him to go ahead.
If Jacob's not here yet, would you like to begin? Would you like to begin?
Go ahead. Here. Can you hear us okay?
Yeah, we can hear you. Can you hear us?
Yeah, we hear you fine. Go ahead and begin your part, and we'll wait for our second speaker because she's not here right yet, so I don't want to waste time right now.
Am I just allowed to ask her a question before I start?
Go ahead. Go.
Yeah. Okay, so you did awesome, like a lot of information. But I just want to ask you, you're saying that it's the oil is formed in a non-biotic way, right? So how long does it take to form? You know, to let's say a certain amount.
How long does it take to form?
Yes.
It's been formed all the time by heat and pressure, so.
So you're basically saying like there's no specific time for it. Like if I was to say from today I started, when would I find, you know, oil forming, or is it just like all the time?
Yes. All the time you would be finding it.
Okay, thank you. Okay, okay, so I'm going to begin. First of all, I just want to say that I've done a lot of research and I've read a lot of information, and what I truly believe that the way of formation of petroleum natural gas, that it's formed by anaerobic decomposition of remains of organisms, including phytoplankton and zooplankton, which are, you know, organisms that were from a long time. So they settled to the sea or the lake or the ocean bottom in large quantities, and you actually mentioned that under under very harsh conditions before millions of years ago. So what happened was that they were buried under mud and you know, heavy rocks and stuff. So there was a lot of heat and pressure that caused the organic matter to chemically alter and transform from one shape to another. So first it was transformed into waxy material known as keroge, which is found in oil shales. And then with more heat and pressure, it was transformed into liquid and gaseous hydrocarbon in a process known as catagenesis. Okay, so the age of the organisms and the resulting fossil fuels is typically, we're going to say about like millions of years, and sometimes it can even be exceeded up to 650 million years. Now, I have a senior research fellow who is called Hodgson. He immersed us in physics at Corpus Christi College in Oxford. He expects the world energy use that it's doubling every 14 years, and the need is increasing faster. As I said, the oil was formed before millions of years, and some scientists even say that this is sort of like a different theory in a different way, that it was actually formed by tiny diatoms, and they are the source of the oil. Now, these diatoms are they're sea creatures that are very small. They're the size of a pinhead. And what they do is something like plants, which they can convert the sunlight energy into stored energy in their body. So what happened was that when they died, they fell to the seafloor, and they were buried under the sediments and the rocks and so on. So as we said, they got buried under the pressure and the temperature, and the energies in their bodies was locked up and it couldn't escape. So that's why we can say in the result that oil can give us so much energy, and we can release from it so much energy. Now the carbon eventually turned into oil under the great pressure and the heat. As the earth changed and moved and folded, pockets of oils and natural gas can be found were formed. And for the idea that you were saying that why is it mostly in the Middle East, is I can simply say it's probably because of the continental drift that happened, because as we know, all the the earth was all it was all in one piece in Gondwana. So what happened was that when the drift happened, the microorganisms and marine species they evolved and diversified, which caused the enriching marine sediments with organic carbon necessary for hydrocarbon generation, and that is why we find it mostly in in the Middle East countries like Yemen, like Iraq, like Turkey, in those areas. What else can I say? Also, I have some evidence that researchers from the University of Texas they have published a peer-reviewing paper that details the rapid decline of shale gas well production. So they reviewed data for more than 8,000 wells over 10 years period, and found that many wells are on track to produce only about 10% of their potential. So this obviously shows to us that the amount of gas it's becoming, it's declining and it's becoming lesser. So if we were to say that it's forming every single day, then we would find the oil amounts in the wells, staying as much as they were yesterday and before yesterday, and that is something that we don't find. I also have from Dr. Tad Padzek, who is the chairman of the Department of Petroleum and Geosystems Engineering at the University of Texas. He says these wells can produce low rates for 25 to 30 years, but in order for us to actually get the high rates, we're going to need to run our economy. So we need to drill more, and we need to look for more, and drill more wells in order to get more petroleum. So for the time being, we have been we've been drilling massive numbers of wells, but with the time it will be more and more difficult, because as I said, a lot of wells have actually dried out, and no more oil is being found in them. It's still being created in nature, and that's a fact that we can't neglect. But as much the rate of it being created is much slower than the rate that we are using it in. So we're using the resource faster than it can reform. So it's going to eventually run out and finish before we get a chance to see the new formation. Okay, thank you.
You can go ahead with your second speaker if you'd like, and then because Jacob's still not here, so.
Okay, so one day we will run out of oil. It's not today or tomorrow, but one day we will. And we have to leave oil before it leaves us, and we have to prepare ourselves for that day, Dr. Byro said. The earlier we start, the better, because all of our economic and social system is based on oil. So to change from that, we will take a lot of time and a lot of money, and we should take this issue very seriously. The market power of the very few oil producing countries, mainly in the Middle East, will increase very quickly. They already have about 40% share of the oil market, and this will increase much more strongly in the future. There is now a real risk of a crunch in the oil supply after next year. We demand picks up because not enough is being done to build up new supplies of oil to compensate for the rapid decline in existing fields. The IEA estimates that the decline in oil production is existing fields is now running at 6.7% a year compared to the 3.7% decline it had estimated in 2007, which is now acknowledged to be wrong. If we see a tightness of the market, people in the street will see it in terms of higher prices, much higher than we see now. It will have an impact on the economy, definitely, especially if we see the tightness in the markets in the next few years. If it will be especially important, because the global economy will still be very fragile, very vulnerable. Many people think there will be a recovery in a few years' time, but it will be a slow recovery and fragile recovery, and we will have the risk that the recovery will be strangled with higher oil prices. Oil production has already peaked in non-OPEC countries, and the era of cheap oil has come to an end. One of the clearest indications that the planet is running out of oil is the fact that discoveries of giant oil fields have slowed so dramatically in the past couple of decades. On the face of the number implies that the world will run out of oil within many our lifetimes, including mine. Even as cars become more and more efficient, the global economy still runs on oil. Is our independent dome coming faster than we anticipated? Predictions are uncertain because they involve estimating amounts of oil in places where nobody looks for, and also because it requires predicting technology improvements that might let us extract oil that we knew about but could not get out before. Recent development of hydraulic fracturing technology is an example. Higher oil prices brought on by a rapid increase in demand and a stagnation or even decline in supply could blow any recovery off course, said Dr. Faith Byro, the chief economist at the respected Environmental Energy Agency, IEA, in Paris, which is charged with the task of assessing future energy supplies by OECD countries. Why is oil so important as an energy source? Crude oil has been critical for economic development and the smooth functioning of almost every aspect of society. Agricultural and food production is heavily dependent on oil for fuel and fertility. In the U.S., for instance, it takes the direct and indirect use of about 6 barrels of oil to raise on 1 beef steer. It is the basis of most transport systems. Oil is also crucial to the drugs and chemicals industries and is strategical assist for the military. That's why we have to find alternatives in order not to finish it. How are oil reserves estimated? The amount of oil recoverable is always going to be an assessment subject to the virus of economics, which determines the price of oil and whether it is worth the cost of pumping it out, and technology, which determines how easy it is to discover and recover. Probable reserves have a better than 50% chance of getting oil out. Possible reserves have less than 50% chance to not get it out. I am done. Thank you. Thank you.
I'm gonna ask some questions.
Okay, go ahead.
If oil is running out, then why has it's been very cheap for the past months and it's getting cheaper?
Or are you can I give you an example like how they found some oil wells in Russia or like that, because that they're saying that there's an increase in its amount. Okay, well I want to tell you something that I read about the refill of wells of oil fields. They have found evidence, like as you said, that there is an increase in oil in some of the wells that have even they were almost empty or have been empty for years. So they found out that they're being refilled. But if the oil was reforming from under, why are all the empty fields why aren't all of them getting refilled? So if we were gonna take the idea that oil is forming from under, we would find it forming more and more in all the wells, not in just a specific area. So according to marine geologist Terry Roberts at Louisiana State University, he says petroleum geologists don't accept the idea of the general phenomenon because it doesn't happen in most reservoirs. So the only explanation is that there are very leaky fault systems that allow it to migrate from one place to another. So basically, it's just from the Earth movement or any other, as I said, a leaky fault system. It's actually just moving from one place and going to another, and we're seeing an increase in its amount. So these amounts, we wouldn't have known of them before. We wouldn't have found out that they're there, but as we find them out, we think it's an increase, but really it's not.
So are you agreeing that it wasn't made by the ocean, that it wasn't found in the ocean?
No, I'm saying that it was already formed, but what happened is that we didn't, the specific areas, there's specific areas that we didn't find them, or we didn't see them, or we didn't open up wells in those areas. And because of other wells that were empty or something, and they were leaky areas from other areas, it got drifted to the other area. But it was already formed.
So the wells refilled weren't found in the ocean?
I honestly don't know about if they were found in the ocean or not, but I'm just telling you about the basic idea.
So they weren't found in the ocean?
Yeah.
Do I ask it again? So they weren't found in the ocean?
I'm not really sure about that, that information, but the wells that were being refilled are in the ocean, so.
So that means you took your whole theory, correct? You took it all apart, correct?
How so?
By saying that we actually found it not in the ocean, but you stated that we did found it in the ocean, and that it was created by plankton, that it's located in the ocean. So does that mean that it wasn't?
Okay, but as I told you, the Earth was, it was in constant moving, and you're not gonna, and especially for oil, it's a liquid substance, so it's not something rare to find it, moving from one place to another.
So you're saying that the Earth was found specifically by earth and gas were found.
Here comes our second speaker. Just wait a minute, and he's finally here. I think her question was, how about, girls, how about the planets like the different satellites they found gas, and methane on, and methane's caused by the same form, I guess, decomposition of biological materials. But if the planet never had biological materials, wouldn't that take out the idea that gas was formed by biological materials?
Can you rephrase the question?
Yeah, one of the startling revelations in the last decade has been that some of these probes that the NASA and other countries are sending up to different planets have found different gases or different, fuels, and they never had populations of biological. You have your speech. Biological stuff. So how do you explain the existence of gas or oil on planets that never had any biological material?
Well, I guess it's gonna come down to the idea that in the end, oil and gas, or it comes down to the organic compound that it's made of. So whether it's carbon or nitrogen or hydrogen or whatever organic compound it's going to be made of, it's going to come down to the idea, is that element there or not. So if it's there, whether or not or it's in an organism or not, I guess that's what it comes down to.
So you're basically saying it's a chemical process then?
Yeah, like in the end, because any organism, when it gets buried, the oxygen is the oxygen, it's all gonna leave that organism, and it's gonna end up with hydrogen and carbon. So if we were to say that hydrogen carbon from a non-organism, source, it would also be correct.
Ask your question, one second.
Wait, what? Want me to tell them?
Yeah, go ahead.
Oh, I was gonna ask. She said that we were running out of oil, so that means that are we running out of water since?
In a hurry.
I'm sorry?
They're in a hurry. Let's go.
Oh, okay. We're ready for me to get into the second speech.
Yeah, go.
Thank you. May it please the court, your honors, I, Jacob Shaw, will now speak on the second point of error. If we know that oil is not biotic in composition, is therefore not finite, why are we still believing the biotic formation of oil? Please classify my partner, Andre Montezuma's points. Let's begin with a brief review of how we got into this subject. The history of petroleum science began in 1757 when the Russian person natural gifts, M. Lomonosov, suggested the hypothesis that oil might originate from biological detritus. During the end of the 19th century, famous Russian chemist Dmitry Mendeleev stated clearly that oil is a primordial living material from great depth, the mantle. The modern Russo-Ukrainian theory of deep abiotic petroleum origins is not new or recent. The theory was enunciated by Professor Nikolai Gurdjieff in 1951, almost half a century ago, and has undergone extensive development, refinement, and application since its introduction. There have been more than 4,000 articles published in the Soviet scientific journals and many books dealing with the modern theory. This writer is presently co-authoring a book upon the subject of the development and application of the modern theory of petroleum, which bibliography requires more than 30 pages. The modern Russo-Ukrainian theory of deep abiotic petroleum origins is not the work of any one single man or a few men. The modern theory was developed by hundreds of scientists and now former USSR, including many of the finest geologists, geochemists, geophysicists, and thermodynamicists of that country. There have now been more than 2 generations of geologists, geophysicists, chemists, and other scientists in USSR who worked upon and contributed to the development of the modern theory. The modern Russo-Ukrainian theory of deep abiotic petroleum origins is not untested or speculative. On the contrary, the modern theory was severely challenged by many traditionally minded geologists at the time of its introduction, and during the first decade thereafter, the modern theory was thoroughly examined, extensively reviewed, powerfully debated, and rigorously tested. Every year following 1951, there are important scientific conferences organizing USSR to debate and evaluate the modern theory, its application, and its predictions. The all-union conferences of petroleum and petroleum geology in the years 1952-65 dealt particularly with this subject. During the period when the modern theory was subjected to extensive critical challenge and testing, A number of the men pointed out there have never been any similar critical review or testing of the traditional hypothesis petroleum might somehow have evolved spontaneously from biological prejudice. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is a vague qualitative hypothesis, but this is a rigorous analytic theory within the mainstream of modern physical sciences. In this respect, the modern theory differs fundamentally not only from the previous hypothesis of biological detritus from biological origin of petroleum, but also from all traditional geological hypotheses. Since the 19th century, notable physicists, chemists, geonemicists, and chemical engineers have regarded with great reservations, if not outright disdain, the suggestion that how reduced hydrocarbon molecules of high enthalpy, the constituents of crude oil, might somehow evolve spontaneously in biological detritus. Beginning in 1964, Soviet scientists carried out extensive theoretical statistical dynamic analysis, which established explicitly that the process of evolution of hydrocarbon molecules, except methane, are biogenic ones in the temperature and pressure regimes of the Earth's surface crust, was glaringly in violation of the second law of thermodynamics. They also determined that the evolution of reduced hydrocarbon molecules requires processes of magnitudes and counter depths equal to such in the mantle of the Earth. During the second phase of its development, the modern theory of petroleum was entirely recast from a qualitative argument based on some many qualitative facts to a quantitative argument based upon the analytical arguments of quantum statistical mechanics and thermodynamic stability theory. With the transformation of the modern theory from a synthetic geology theory argument of persuasion into an analytical physical theory argument of propulsion, petroleum geology entered the mainstream of modern science. The modern Russian-Ukrainian theory of deep abiotic petroleum origins is not controversial nor presently a matter of academic debate. The period debate about this ancient body of knowledge has been over for approximately 2 decades. The modern theory is presently applied extensively throughout the former USSR as a guiding perspective for petroleum exploration and development projects. There are presently more than 80 oil and gas fields in the Caspian district alone, which are explored and developed by applying this perspective to the modern theory that was produced from the crystalline basement rock. Similarly, such exploration in Western Siberia Cratonic Red Sedimentary Basin has developed 90 petroleum fields, which 80 produce either partly or directly from the crystalline basement. The exploration discoveries of the 11 major and 1 giant fields in the northern flank of the Denver-Donetsk Basin have already been noted. There are presently deep drilling projects underway in Uzbekistan, Kurdistan, and Siberia directly to test potential oil and gas reservoirs in the crystalline basement. It appears that, unbeknown to Westerners, there have actually been for quite some time now 2 competing theories concerning the origins of petroleum. One theory claims oil is an organic fossil fuel deposited in finite quantities near the Earth's surface. The other theory claims that oil is continuously generated by natural processes in the Earth's magma. One theory is backed by massive body of research representing 50 years of intense scientific inquiry. The other theory is an unproven relic of the 18th century. One theory anticipates deep oil reserves, fillable oil fields, migratory oil systems, new sources of generation, and spontaneous venting of gas and oil. The other theory has a difficult time explaining any such documented phenomena. So which theory have we in the West and infinite wisdom chosen to embrace? Why? The fundamentally absurd philosophy theory, of course. The same theory the peak oil doomsday warnings are based upon. I'm sorry to report here, by the way, that in doing my homework, I never did come across the end of that hard science documenting peak oil that Mr. Shaw referred to. All the peak oil literature that I found on Riverside and elsewhere took for granted that petroleum is a non-renewable fossil fuel. That theory is never questioned, nor is any effort made to validate it. It is simply taken to be an established scientific fact, which is quite obviously is not. First, look at the abiotic hydrocarbons in space. Carbon is the 4th most abundant element in the cosmos, and remote observations indicate that the universe is replete with organic compounds produced without the influence of biology. Studies of the absorption spectrum of these molecular clouds reveal more than 150 small molecules. The greatest amounts of hydrocarbons in the solar system are associated with the gas giant planets and the satellites, where significant amounts are present in atmospheres and on icy surfaces. The presence of non-logical hydrocarbons in other states of our solar system is evidenced by the chemistry of our carbonaceous meteorites, which represent fragments of ancient meteorites, or asteroids, unchanged shortly after the birth of our solar system. Carbonaceous meteorites contain percentage levels of organic matter that were generated in the absence of biology. The widespread presence of organic matter in the cosmos suggests that no exotic mechanism therefore need be invoked to propose abiotic hydrocarbons on Earth. In fact, the biogenic origin of some hydrocarbons on Earth is, thus far, a unique observation in an abiotic hydrocarbon-rich universe. In contrast to our cosmic environment, organic matter on Earth is associated primarily with biological processes. The distinction between biological and non-biological organic matter is held long-term fascination for scientists and philosophers. For instance, all ancient mythologies invoke divine intervention and uses an abstract vital force for the production of organic compounds that constitute life. Following the 7th and 6th centuries BC, such vitalist theories were often challenged by materialistic concepts that assume only differences in levels of organization between living and non-living entities. A key moment for materialism came in 1828 when Friedrich Wöhler produced organic chemical urea from inorganic ammonium cyanate, and used a procedure now called the Wöhler synthesis. Generation of organic compound for inorganic material flexibility of non-biological processes to produce organic molecules, and it is an unavoidable conclusion that the origin of life on Earth would better finish the process of abiotic organic synthesis. In general, organic compounds generated by abiotic reactions, such as those that produce meiotic organic matter, are characterized by complete structural diversity. Biological organic compounds produced by synthetic reactions directed by enzymes are notably specific in structure. Organic compounds, petroleum, by contrast, containing numerous structures in abundances that cannot be produced by the random polymerization from methane. Second, experimental hydrocarbon synthesis. Hydrocarbon synthesis is achievable under laboratory conditions and in shallow geological environments, and several key reactions are notable. First, Fischer synthesis involves the conversion of carbon monoxide or carbon dioxide to hydrocarbons. The products of Fischer synthesis are low molecular weight hydrocarbons and often form a two-story distribution where the log of hydrocarbon concentration decreases linearly with increasing carbon numbers. The Fischer process has been produced as a generated of hydrocarbons in hydrophobic settings. Second, metamorphism of carbonaceous calcite, dolomite, and siderite at 400 degrees Celsius and present hydrogen gas can produce low molecular weight hydrocarbons. Third, metamorphism of carbonates and graphite below 240 degrees Celsius may generate methane. Fourth, methane is common in meadows from ridges, and turbidinisation reactions are implicated. Hydrogen forms from the hydration of olivine and can combine with carbon dioxide to form methane. In addition, for those reactions that proceed under conditions relevant to Earth's near surface, influence of pressure may be an important factor for synthesis. This environmental control is especially pertinent to the series of deep gas and a number of experimental studies at elevated temperatures and pressures relevant to deep pressed natural conditions point to the possibility of deep abiotic hydrocarbon synthesis. First, the generation of petroleum hydrocarbons, the C10H22, was demonstrated using solid iron oxide, marble, and water temperatures at 1400 degrees Celsius and pressure over 3 gigapascals, corresponding to a depth of more than 100 kilometers. Second, a diamond anvil cell have been employed to export a calcite iron oxide water system at mantle pressure and temperatures. Based on Raman spectroscopic and X-ray diffraction evidence, methane and possibly other light hydrocarbon species were successfully synthesized. Experiment suggests the first attempts to test the Russian-Ukrainian school of hypothesis under conditions comparable to those found in the mantle. Subsequent experimentation has successfully repeated the observations. Third, pressures about 2 gigapascals and temperature from 1,300 Kelvin appear to induce polymerization of methane to hydrocarbons, such as ethane, propane, and butane, like hydrogen and graphite. The reaction is reversible under these conditions. Although elegant and efficient reactions exist that can produce substantial amounts of hydrocarbons from simple precursors in absent biology, care must be taken when translating data to natural settings. Convincing evidence must be found in the production of mechanisms contributing. Lessons can be learned from meteoritic organic matter studies where the tridimensional synthesis mechanism was supported even though ample evidence was available, the reaction was not contributing quantitatively significant amounts of material to organic inventory. Third, hydrocarbons and minerals. Evidence has been presented from organic photomolecule assembly in igneous rocks. According to Froom's hypothesis, igneous most inevitably incorporate carbon and other impurities at high temperatures. As minerals crystallize, they also incorporate a small amount of carbon, which concentrates along linear crystal defects and form alkanes. However, these results have been challenged by other workers. Fourth, abiotic hydrocarbons from hydrothermal vents. A number of authors have presented experimental, theoretical, and field evidence for the possible release of abiotic hydrocarbon used for hydrothermal vents. Hydrocarbons have been collected from numerous field sites. Observations of gas chemistry, abundance, and flux in various vent settings have provided an opportunity to assess quantitatively the relevance of proposed abiotic species to commercial oil and gas resources. Mean values of molar CO2 helium and mantle-derived fluids imply less than 200 ppm of abiotic gas are present in economically relevant reservoirs. These field observations of hydrocarbons from hydrothermal systems have been complemented by experimental studies that attempt to replicate natural conditions. A number of these experiments have been demonstrated abiotic formation of methane and other organic compounds, particularly in studies that mimic serpentinization. Experiments underscore the importance of transition elements and the hydrothermal synthesis of organic molecules by Fischer reactions. These results suggest an intriguing connection between mineral, mediated organic synthesis and biological catalysts, many of which incorporate traditional metal atoms at their active sites. Biochemical reactions formed by enzymes that incorporate traditional metals may thus represent reaction pathways that have survived and evolved in a pre-biotic geochemical world. Constitute the main argument put forward by Western biotic oil theorists is that biomarkers always found success organic detritus within all oil deposits, which is certainly true. But unfortunately, oil exists inside the earth and is surrounded by different types of geological soils, which all contain organic detritus. And oil is a wonderful solvent in which to dissolve and hold detritus. Also, and by the reverse argument, alkanes, carriages, and many other petroleum-related chemicals have been found in meteorites, but can support no organic life. Crossed by the fact no fossils have been found below 15,000 feet, the oil is being currently drilled up for 40,000 feet. They're left with a controversy. Why are we not told the truth? 7 reasons why we're not told the truth about the sources of oil. First, in his paper, The Abiotic Oil Controversy by Richard Hamburg, which titled Abiotic Oil, with relatively little actual quoted research evidence, has even admitted there is no way to conclusively prove that no petroleum is of abiotic origin. Perhaps one day, there will be general agreement that at least some oil is indeed abiotic. Maybe there are indeed deep methane belts 20 miles below the Earth's near surface. But the important question to keep in mind is, what are the practical consequences of this discussion now for the problem of global oil depletion? Talks about the facts, can't prove this. Talks about some maybe. Although by doing this, the abiotic oil theorists are really tearing down their own theory. Talks about the real problem here for the abiotic oil theory is not how oil is created, that it is running out. This is a logical fallacy, creation of a false dilemma. How can one of a product that is virtually unlimited? Second, American geologist King M. Hubbard predicted in 1956 that peak oil for the USA will peak in 1970. However, in December 2014, the United States once again leads the world in production of oil, actually producing more oil than it did in 1970. Caused by the fact that oil price in December 2014, fell by over 50%. If Hubbard's theory of peak oil were correct, neither of the two facts would have taken place. Clearly, peak oil and the price of oil are trying to manipulate the demand of oil by creating a false sense of running out of oil. With limited supply, demand and prices go up. Caused by the fact that the supply has gone up, prices have gone down, causing the best for the peak oil as a theory is completely dead. Third, caused by the fact that the law of thermodynamics prohibits spontaneous evolution of liquid hydrocarbons in a regime of temperature and pressure characteristic to the crust of the Earth. One should not expect to exist no legitimate scientific evidence that such could occur. Cost supply, there is no such evidence. Nonetheless, and surprisingly, there continue to be often promulgated diverse claims purporting to constitute evidence, and natural petroleum somehow evolves miraculously from biological matter. Fourth, oil is often called a fossil fuel. That data being comes from former living organisms. This may have been possible back when oil wells were drilled into the fossil layers that are suppressed. Today, great quantities of oil are found in deeper wells that are found below the level of any fossils. How could an oil come from fossils or decomposed former living matter if it exists from rock formations far below layers of fossils, the evidence of former living organisms? It must not come from living matter at all. 2 days after I read this statement, I encountered the following statement in a newspaper I deeply respect. Any geologist will tell you, well, most geologists will tell you that oil was created by the magma of the earth. The oil wells in Pennsylvania that were pumped out dry at the turn of the century and capped are now filled with oil again. Say what? It's a response from Daniel E. Reynolds on July 29, 1996, from the subject of oil, a renewable and abiotic fuel. Caused by the fact, the only reason we're still being taught that oil is a fossil fuel is to control the price of oil and to aid in the story that we're running out of oil. Fifth, Academy of Sciences, Moscow. For almost a century, various predictions have been made that human race is imminently going to run out of available petroleum. The passing of time has been proven all the predictions have been utterly wrong. Caused by how all predictions have depended fundamentally upon an archaic hypothesis in the 18th century, petroleum has somehow miraculously evolved from biological densities and is accordingly limited in abundance. The hypothesis have been replaced during the past 50 to 40 years by the Roger creating theory of deep abiotic petroleum origins, which has established petroleum as primordial material other than great depth. Therefore, petroleum abundances are limited by little more than the quantities of its constituents as were incorporated into the earth at the time of its formation, and its availability depends upon technological development and exploration competence. Discovering commercial oil and gas rights in Croatia, Tunisia, Libya, and other areas. Until the 12 oil and gas fields discovered worth $4.38 billion in prices of 1991, and $6.3 billion prices of 2008. For the discovery of these new oil and gas accumulations, various scientists were awarded the state prize of Ukraine in the field of science technology in 1992. Today, there are 50 commercial oil and gas fields known as DDB's Northern Flank. Data obtained from drilling in many of these areas show the crystalline basement Northern Flank consists of amphibolites, trichonites, diorites, gneissites, granites, granodiorites, granitogenesis, migmatites, piterites, and schists. 32 commercial fields have oil and gas accumulations in sandstones of the middle and lower Carboniferous age. 16 other fields contain reservoirs in the same sandstones rapidly from them. Amphibolites, granites, and granodiorites in the crystalline basement as well. 2 fields contain or pool pools in the crystalline basement only. 7th, a Russian book, Adventuring Solutions, detailing deep and ultra-deep drilling technology below the Earth's surface, demonstrating layers to depth of over 4,000 feet. And it occurs in quantity in geological domains where oil is relatively rare to absent, within oil and trust belts, and some large basins such as West Siberian and Semi basins, and depths below 15,000 feet. Natural gas has been found at 21,000 feet in the granitic rocks of Sweden's Solgen meteorite impact crater, and the deepest depths, drilled in the Earth in Oklahoma, 1,441 feet, and 40,000 feet in Kola Peninsula in Russia. It's peculiar. There have been so little Western synthetic peer review or acknowledgement or research verification concerning the ultra-deep Russian abiotic formation theory. Surely this is sufficient and bears investigating, even if you don't believe in the theory. But this will certainly remove the geopolitical effects and problems of the current tank of oil that is running out. Considering this theory, I've shown you why it is wrong. In the end, you have to agree to Russian abiotic theory of oil formation, and by all this evidence, it's far more likely to have been the true explanation. And there appears to be little or no conclusive evidence for the Western abiotic theory of oil. But at any of us totally much unanswered, doesn't it? For what reasons then, why these fact conclusions is the peak oil theory being so heavily touted? A theory that is wholly dependent on the Western abiotic theory of formation of oil, which as I see it, is completely unproven theory. As Western geologists and scientists believe that's super unfair, or it's an underlying hidden agenda in media steerage here by the big oil major OPEC, and perhaps discreetly encourage higher oil prices to promote a false scarcity of the resource by conveniently supporting the Western abiotic theory of oil formation. Now just proven defunct, so heavily promote hubris or peak oil theory. Follow the money. The only one to gain from this taunting this theory are oil companies themselves. They push oil to record heights and held the developed world hostage to their whims. Then in summer 2014, a break-in stranglehold they held on OPEC on the exporting of oil. This is because of national greed and the fact that the U.S. is now producing vast more tons of oil. Prices have dropped by more than 50% from June 2014 to December 2014. I view this question unfair. Could oil actually have lost 50% of its value if running out of it? And why is it large oil companies have never really invested heavily into other forms of energy? It's because they know, like my partner and I do, they do not have to, because they will never run out of oil. I pray that you find for the petitioners in this case and vote for promotion of the truth. Thank you for your time. Don't further questions, I will retire. And with that, if you have any questions about our arguments today or the second speech, I'd be more than happy to answer.
Okay, here's a question. If oil originates from non-biological compounds, as you said, then could you tell me what happened to all the organic compounds of the dead plants and animals millions of years ago?
So, what organic compounds that are in there, we're not dying today, guys, just inside the earth. With them, we believe that they're either found in fossils, they become relegated to fossils, that have simply just deteriorated over time. However, they simply haven't contributed to the formation of oil because, again, as you said already and agreed, the oil originates from non-biological material. And fundamentally, it's found at depths thousands of miles lower than that of any biological material, such as plants, decaying plants, and dinosaur bones and things of that nature.
Thank you.
Any other questions?
No more questions. Thank you.
Thank you.
So I have a question about the peak oil theory. So believing in the biotic formation of oil, the oil is finite, it's going to be running out. But this is something that we're also saying about in the 70s, and King and Hubbard, American geologists, said that in 1956, USA was going to peak oil in 1970. But again, as we said, last year in 2014, prices of oil dropped by 50%, and USA is now the leading producer in oil again. If oil is finite resource, biotic, how is this possible to have happened?
So we're back to the idea that how is it becoming more after it was becoming less, right?
Precisely, and not just that, but also the dropping in price.
The drop. Okay, well, when you have something, the amount of it is becoming more. Obviously, the price of it is going to drop because there's more of it. And I actually told Andrea or Andriana, the basic idea of that is that in some places oil we actually find it, and when it would be like a leaky area or something, and the well, when it's empty or it's about to be empty, or when it has a lesser amount of oil in it, what happens is that it drifts from one place to another. So we think that. But originally, it would be already oil that has already formed from before. It just moves from one place to another.
Right, but in those cases, for example, How is it possible that oil is found thousands of miles below any fossils or formerly living organisms if they're here and oil is found at such greater depths? How is it impossible that they created the oil or resurfaced the oil and contributed to the formation of that oil when they're so far above them? That's literally impossible, correct?
Okay, well, I'm gonna go back to the continental drift idea, and you know how so much cracks happen in the earth, and you know the earth becomes in different levels. So I'm gonna say that the reason for that is, you know, the different levels of the you know the inside of the earth. So we're gonna find some stuff, you know, downer as oil, above it gas, more to the, you know, to the top, fossils, you know, and so on.
So you're saying it is possible to find oil at depths thousands below where you would find any formerly living organisms because the tectonic plates are always shifting and that's causing it to sink?
I guess we can say that. We can say that these shifts are gonna cause a change in place for the oil or the organic compounds.
Right, but the organic compounds are dropping, they're not dropping any lower, but oil is continually being found lower. So how does that work? The oil is being continually found lower, but the organic compounds staying in the same place, thousands of miles higher than you would find any oil. For example, to give you some examples, the Kola Peninsula in Russia, we're dealing over 40,000 feet. In Oklahoma, we're dealing at over just above 31,000 feet. And what was DDB's northern flank? Oil's drilling there in Ukraine. So I don't see how at those places you're drilling at so many miles deeper than you would find any organic material. Even tectonic plates again, if you're talking about a shift, that wouldn't make sense because the oil is being found lower, but the organic material is never found shifting whatsoever. So you think you could clear that up?
When we're talking about a liquid substance, it obviously means that it's easy for it to move from one place to another. So, like, I mean, in conclusion, we don't really know. I mean, for me personally, I don't really know what really happened, you know, because, you know, we're not living in the middle of the earth and we don't know what's going on. But I can say that it's a big possibility that, you know, it's easy for it to move from one place to another, so that we can find it in different levels. But as you said, fossils of you know, different organisms and so on, you know, as we said, they're going to harden, or they're just going to leave a mark in the rock. So, you know, that's, as we said, it's hard for that to find it in different levels.
Right, but on that account, so we're going back to about formerly living organisms, and you're talking about fossils again. And I like to answer this kind of a scenario for me. So, for example, if there's a limited number of fossils that were ever created, there's a limited number of dinosaurs, we're an infinite amount of dinosaurs. And my partner brought this up earlier, I'm sure, but how could that many of dinosaurs died at the same time in the same place to produce the amounts of oil we're talking about? I mean, don't you think it's a little bit preposterous that all the oil is coming from fossils, especially when oil is found in so many diverse places, but dinosaurs weren't on every place that you find oil. It was the fact that fossils decay over time. There's not the amount of fossils that we found aren't conducive to the amount of oil that the world has ever produced.
Okay. Well, when we're going to say that some of the organisms became oil and some of them became fossils, obviously the amount of fossils is not going to represent the amount of living creatures that live, because once the creature, or, you know, the layer goes down to a point where it's becoming into a liquid phase, there's nothing left to see of it, of a fossil. So the fossils we are seeing, they're just on the upper level. So maybe we can assume that they were like they were after or something. But anything that went under to a level to be to the heat and the pressure, you know, it becomes, you know, like a magnet texture. So you can't really say that the amount of fossils represents the amount of creatures or.
Right, but for example, going back to the whole liquid aspect, even then, again, that wouldn't explain the diverse distance between where you find fossils or any form of living biological matter and that of oil. But further, and it's probably going to be wrapping up for my last question for you, If you're still on the foreign living organisms side of the aspect, debate not believing in a distance aspect or the fact that there can have been that many dinosaurs that died in the same places. What about the fact that you find the constituents of oil in space on various planets where life cannot be present, where life cannot be formed, but you find these same biological materials that make up oil? If oil can exist in those places, I'm sorry, not oil exactly itself, but if, sorry, the constituents of oil can exist without the presence of any biological material, certainly can exist on Earth as well, without any biological material.
Yeah, so we actually talked about this too, that like we believe that it comes down to the organic compounds or the basic specific compounds that it's made of, you know, as carbon and hydrogen, whether the source is something organic or non-organic.
So you're saying that carbon and hydrogen can be made from different processes, one organic and one inorganic?
I guess it's possible. I mean, if we're finding oil or gas in a planet where they're saying that there wasn't any living creature.
Do you have any scientific basis to support that?
I honestly don't, but I don't know. I'm building it on the information that you guys gave me, that on different planets and so on.
Because I'm just saying, it seems it would be more plausible to suggest that because these constituents of crude oil can be found on planets that can support no life, it would be more plausible they could exist on Earth, again, in the absence of any biological material, rather than you're saying that it can be produced one place without life and another place with life. But you think it's easier and more factual to believe that it could just be formed without any biological help or any biological foundation?
Okay, but then we're going to take all the information that you know, many of scientists have been building on, and you know, we're just going to completely deny it. I don't really think that's a reasonable way, because it's you know, it's something that it's pretty scientific, and you know, a lot of evidence gives us, you know, this information that it's true.
I'm all for the process of science, but I'm also for the process of making sense logically as well as factually and morally. And, you know, we've listened to scientists for decades, various scientists from both sides. And for example, King M. Hubbard in American Geology in 1956, it said oil would peak in 1970 for the United States. In other words, it would cease to exist and we run out of it. Well, here we are in 2015, and the leading producer of oil again, and prices dropped over 50% last year. So in America, these scientists have said oil is indeed biotic in composition. Their predictions have been continually proven false, decade after decade, when saying we continually run out. It cannot place a cap on us. We keep producing and proving them wrong each time. So how should we continue to listen to these scientists who are attesting to oil companies?
Okay, but if we're gonna take the idea that in fact that it's not from something from living creatures or so on, then how come we like they haven't noticed a rise in its amount before? Like why now? Why in this year? You know, assuming the idea that I told you, that, you know, just leakages are happening or whatever, so it's moving from one place to another. Why not before? Why not in the past years, the past thousands of years? Why haven't they found an increase in the oil if as you say, it comes from something inorganic? They
have. It wasn't just this year. It's just probably the most prominent example. But for example, my debate coach was going to high school. They told him by 2000, the U.S. was going to run out of oil. Texas was going to run out of oil. But here again, Texas is the largest producer of oil in the United States. Again, in King M. Hubbard, the geologist, in 1956 said oil was going to peak by 1970. But every decade thereafter, we've continued to produce oil. So effectively, it has increased. But when talking about the Russian-Ukrainian model, that I guess Stalin first instituted, it was established during World War II to do Russia could continue to produce oil and really industrialize. A lot of the factors contributed to why it's not very prevalent in the United States, for example, and a lot of the world, is because one, United States versus USSR in the Cold War, anything seen as Russian were heavily against, whether it be the abiotic formation of oil or not. Second, even if you did want to believe in the abiotic formation of oil, the Russian-Ukrainian theory had, because it was in Russian, it was never really translated, it's hard to analyze it and incorporate it into our mainstream of our sciences in America or around the world. And probably the most prominent reason is oil companies can benefit economically much more, and they keep us believing there's a scarcity. But this false scarcity keeps us not only in the dark, allows oil companies to charge whatever they want. And you see, the real question is, if that's true, is what your theory is actually true, why have oil companies never heavily invested in any other type of energy? If you know that their product is eventually going to run out. In that sense, it doesn't make any kind of sense at all. It's preposterous.
Okay, but then why didn't the increase and the reformation happen in all the different oil wells that we have, not in just some specific area? If it's going to keep, reforming on and on and on, then why isn't it everywhere?
It increases everywhere because oil is made everywhere inside, well, not everywhere inside the earth, but it's made in the earth, reduced area in various places, and it's primordial. The earth, it's continually making it, so Earth is always making it, and it's made it for thousands of years. We keep reaping the benefits of oil that's inside the earth, which is why it increases. We have to wrap it up here. If you had any further questions, I'd be happy to answer, but at this time, I think it'd be a good place to conclude our debate today. If you had any...
No, I think we have no more questions. You guys did more than...
Well, thank you so much for your time today, and it was a wonderful debate.
Okay, thank you, too.
Thank you.
Really enjoyed your time. Thank you.
Bye.
Good job.
Thank you.